want to give you one more example of graphing and looking at the domain and range for piecewise functions. This one is a little more complicated than the one we did in the previous video. Here the function is defined, given by the rule of f of x equals x, the output is x if x is greater than 1. We also get x squared if x is less than or equal to 0. So once again, our x's, I'm just going to put a little bit below, our inputs are on the right-hand side, and our outputs, our y's, our f of x's, are on the left-hand side. In the previous video, I believe I did like x for x greater than 1. In this one, it's specifically, I made sure I went back and looked at the book's notation. It says x if. For or if in between them, it's the same thing. It means the same thing. Once again, I'm going to look and see if I recognize any of the shapes. Well, if I look at the first part for x is greater than 1, I'm expecting it to look like a line because the equation is y equals x. For x is less than or equal to 0, we have x squared, so I expect to see part of a parabola. I'm also going to draw my inputs and then a way to calculate my outputs. So here I'm going to start with x, and then I'm going to say for x I'm going to put up here is greater than 1 to remind me that that's the only time I can plug in is if x is actually greater than 1. That rule is y, or f of x, equals x. The second column I'm going to have to give me points to graph is x for x is less than or equal to 0. And that, the rule is y equals, or f of x equals x squared. I suggest focusing on one column or other at one time so you don't get yourself confused. Now, what a lot of students, let's look at the column to the left where we have x and y equals x. A lot of times students want to start at 2 instead of at 1. But remember, we're starting really, really, really close to 1, like at 1.00000001. So the first point we want to look at is at 1. Now I'm going to put an open circle there to remind myself that I'm going to be really close to, but not quite at 1. But we do need the output at 1. So if I plug in 1, I'm going to get 1. If I plug in 2, I'm going to get 2, because remember, I'm only looking at x is greater than 1, and then 3, and I get back 3. Now, looking at the second column, I notice the very first value you can put in is 0. I'm going to put in a filled-in circle there, because it reminds me that it's less than or equal to 0. So that's a definite point. We want to include the 0. Plug in that into x squared, I get back 0. Now it's tempting to say, oh, I'll plug in 1. This is where students go wrong. No, it only has to be x is less than or equal to 0. So the next point I would naturally plug in would be -1. -1 squared gives me 1. And then if I plug in -2 and I square it, I'm going to get 4. So now I draw my axes, labeling, of course, x and y. I suggest graphing one column at a time. That way you don't get yourself confused and connect points that shouldn't be connected. So I'm going to start with 1, 1, and I'm going to have an open circle. And then I'm going to go to 2, 2, put a little point there, and then 3, 3. Sorry, it's a little hard to be really precise with this tool. And then I'm going to draw my line. That takes care of that first column. So now we know it looks like what we would expect. It's a straight line for x is greater than my input. In other words, x is greater than 1. Now let's look at our second column. Our first input is 0. And it's a filled-in circle because it includes it. So I'm going to put a nice dot filled in, of course, because it includes the 0 at 0, 0. Then I'm going to do -1, 1, and then -2, +4. And I'll try my best here to hit the points. Just a little hard with this tool. Okay. And that's going to look like a parabola. And it doesn't. It's just what I expected. Now, that's the graph. Done. And people are like, well, but there's a hole. Let's see, let me just fill this in here. There is a hole between 0 and 1, and yes, there should be, because there's no definition, the function is not defined between 0 and 1. So let's now do the domain and range. The domain, well, looking at the graph or looking up above at the x at your inputs, given the rule, given your function, I notice I can go from negative infinity up to 0. Now I'm going to have a hard bracket there, and I'm going to stop. And then there's a hole in my graph as I go across that x-axis, and I'm going to start up again. In other words, union with, I'm going to start at 1, and once again I'm going to go to infinity. Now my range, if I look at it, I'm going to start in my y values, go down to like negative infinity, go way down in the chart, and start working my way up, 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 up. The first value I'm going to hit is 0, and that's included. Now you'll notice there is always an output from 0 to infinity. Sometimes students want to say, well, but there's a hole. Well, there's a hole in x, but every y value, there's actually, if you look, there is an output because we have x squared. You look at that curve, you can see there's always something there. I hope this helps, and this completes section 2.1.